And our next question for number 6. So circle A shown below has parts B, C, and D marked on it with measure angle DAB equals 48 degrees as shown. Well, that's shown. Segment BC is a diameter. Find the following arc measure. Okay, so here, angle BAD is a central angle, and by central angle, okay, central angle of a circle, angle whose vertex is the center of the circle, whose sides are radii of the circle. The measure of the central angle is equal to the measurement of the arc intercepted by the angle, the arc caught in the mouth of the angle. Okay, so the angle whose center's vertex is going to be the center and whose sides are radii. So let's go back. And so for angle BAD, we'll trace out here. The measure of the arc would be arc BD 48 degrees because it's equal to the measure of the central angle. So that's going to be 48 degrees. Arc DC, well, since BAC is diameter, that would mean that it divides the circle in half, and therefore angle DAC would be, well, 180 minus 48 would be 132 degrees. So this would be 132 degrees. And here, for this angle, angle DAC, arc DC would be also 132 degrees. Arc BC is the semicircle, So since here, this is 180 degrees for angle BAC, arc BAC will also be 180 degrees. And it makes sense because a semicircle is half the measure of a circle. And now for 1/4 of arc DBC. Okay, 1/4 of arc DBC. Well, arc DBC, so again, follow letters. That would be, in this case, arc DBC, the measure arc DBC would be equal to 180 plus 48, which is going to be 228. So we're going to be working with 1/4 of that. So 228 divided by 4. So 228 divided by 4 is going to be, well, 22. 4 goes 22 5 times the remainder of 2. 28 divided by 4 is 7. That would be 57 degrees. Okay, and then the last part, for, in this case, arc DCB, this big arc here, we're doing 1/4 of that. So the measure arc DCB is equal to, well, 132 plus 180 is going to be 312. Okay, so we want to do 312 divided by 4. Well, 4 goes to 31, I believe, 7 times. All right, with the remainder of 3, because 21 minus 28, 31 minus 20 is 3, and I get 32. 32 divided by 4 is 8. Therefore, this will be 78 degrees. Okay, so a lot of this is going to keep in mind that you have to label your information here, and so just it doesn't hurt to do this now. Okay, a lot of you guys like doing stuff in your head, but just be cool with labeling stuff. You should be okay. All right, and now for question number 7, the reasoning part. So for the reasoning part, it says here, one theorem for circle geometry is the following. In a circle, if 2 chords have the same length, then the arcs cut off by those chords will have the same degree of measure. For example, in a diagram below, AB is equal to CD. So the measure AB equals measure CD. Therefore, the measure arc AB equals the measure arc CD. So they want to show this now. Okay, well, here we go. Draw radii OA, OB, OC, and OD. Okay, so we're going to draw the radii here. So here's OA, OB, OC, and OD. Okay, they explained why triangle OAB and must be called triangle ODC. Okay, well, we are given that AB has the same measure. Therefore, AB is congruent to DC. So we know if AB equals CD, then AB is congruent to CD. And our reasoning is if two segments have the same measure, then they're congruent. We also know that OA is congruent to OB, which is congruent to OC, which is congruent to OD. In this situation, all radii of a circle are congruent. So we now know that these segments are all congruent. Well, shucks, we have everything we need. We can make the statement that triangle OAB is congruent to triangle ODC because if three sides of one triangle are congruent to three sides of another triangle, the two triangles must be congruent. This is known as the side, 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 congruent to side, side, side theorem. Okay? So we know in this case that if we can construct the line segments OA, OB, OC, and OD because just draw a line segment now, and we know all about all the radii of so-called congruent. We can show the triangles of congruent using side, side, side. Okay, please make sure you explain these things. Okay, like not just say hey they're congruent. No, for example, for this statement here of AB congruent CD, we want to say in this case if two segments have the same measure. Two segments have the same measure, then they are congruent. Okay, so ladies and gentlemen, that's again we're going to give reasons for why things are a certain way. Okay, so the second part is going to be given that triangle OAB is congruent to triangle ODC. Now you've proven this. Why can we say that arc AB, measure of arc AB, equals the measure arc CD? Okay, well, first off, we can make the statement here that angle DOC is congruent to angle AOB. Okay? That these two triangles are congruent. And so in this case, if they're congruent, the reason is because corresponding parts, and I'm going to type this in here because my handwriting is dreadful. So I'll put a little font here. Sorry, small font. Okay. Okay, our reasoning would be in this case. Oops, you can now see how bad I type. Corresponding parts of congruent triangles are congruent. Okay. That would be the reason for the triangles be congruent. We can then make the statement in this situation that the measure of angle DOC is equal to the measure of angle AOB. And we'll say in this reason, if two angles have the same measure, then they are congruent. Okay, let's move this up a little bit. All right, so now we got the angles are congruent, and now we're going to go with the following. One of the things talked about in this case is that if the measure of the central angle is equal to the measure of the arc intercepted. So we can make the statement here, all right? So the measure of angle DOC equals the measure of arc DC. And I know what you're thinking, this sounds like a proof. Yes, it does, okay? And you will have to do this as well. So the measure of angle DOC is equal to measure arc DC, or arc CD. I think they want to use CD, so I'll use CD. And the measure of angle AOB equals the measure of arc AB. And our reasoning for here would be if, not if, the measure of the central, a measure of a central angle is equal to the measure of the arc intercepted by it. It's one of the things we mentioned before early on. So, and now, because the angles are going to be equal to those arcs, and measure the angle DOC equals the measure angle AOB, we will then say the measure of arc AB is equal to the measure arc CD. And finally, to fill us out, we will then give the reason a quantity may be substituted for its equal in any expression. I'll put a little quotation mark in the front too as well, just to finalize out. Okay. So that's what it comes down to. Now, all this logical thinking is that, okay, why is this true? Well, we know the triangles are congruent, corresponding parts of congruent triangles are congruent for the angles. The angles are equal to the measure of the arc intercepted, and therefore we can then say that there was by substitution. Yes, that's going to be substitution, ladies and gentlemen. All right, I just write it all out. So by substitution, we can prove that the two measurable arcs must be the same. So from this point, we would then say, okay, that here's this theorem that we go back to the very beginning that says in a circle, if two chords have the same length, the arcs cut off by those chords will have the same degree measure. So this is really important then. So this will again be one of those things we can use later on. So now we're gonna bold it and italicize it and underline it. Okay, so it's not just a problem we do here. For a whole problem, it's going to be one of those things we use later on. So if you want to see the whole page, all right, this is what it looks like. Okay, I'm not sure why those. Oh, I see. Kind of cut off, I guess, a little bit. So those little pieces there. So I'm gonna move this up a little bit. Okay, yeah. All right. So this is the homework assignment for I believe it was a 16 on just the central angles of a circle and also parts of a circle. If you have any questions, please leave them down below in the comments. And when you have comments, please leave them down below too. Let me know how I'm doing, or if there's anything you want to see done. Look out for the next video that I'll be working on the next type of angles of circles. Please leave a like if you found this video helpful, and subscribe to the channel if for updates on any new video content that comes in. I appreciate you guys watching, and hopefully the goal is to be able to learn while we're still while we're still stuck at home. But also, ladies and gentlemen, knowledge is the most important thing. Okay, so hopefully this is helpful to give you more knowledge on these circles. Have a great day, take care, and be safe.